So now we want to look at solving higher order polynomial equations. And we can use factoring to solve higher order polynomial equations. Now, sometimes it's helpful on these if we do a substitution. And I'll show you an example of what we mean. If you look at number 1, we're solving u squared minus 3u minus 4. So I'm looking for factors of negative 4 that add up to negative 3. And since we want that to be negative, we need the larger number to be negative, so we're going to do 1 times negative 4. That adds to negative 3. Coefficient of the squared term is 1, so we can go immediately write down what the answer is in terms of the factoring. It's going to factor in u plus 1 times u minus 4. And then we just go through and set each factor equal to 0 and solve. So this gives me, I don't know why I'm trying to write y's, my bad. This gives me u equals a negative 1 if I subtract 1 from both sides. On the second one, I need to add 4 to both sides. So those would be my two answers, negative 1 and 4. Now, if I look at this next one, well, instead of having squareds, I got an x to the 4th. Instead of having x, I have x squared. And well, we haven't talked about how to solve that. But notice, it's really almost the same as this. In fact, if we let u equal to x squared, this means that u squared equals x to the 4th. So I can rewrite this as u squared minus 3u minus 4 equals 0. So I'm making a little substitution to make this easier. I'm just going to go and say, well, I want to have just a variable here, not a variable squared, so I'm going to let u equal to that variable squared. That means this is going to be u squared. Make my substitution. That then becomes what we just did over here. Now we'd go through and we'd factor it the same way. We would set each equal to 0 and solve. Oh, I guess we don't need to do that. So I'm going to save one step. So that gives me u equals negative 1 and u equals positive 4. Now, we weren't really solving for u, we're trying to solve for x. But keep in mind, u is the same thing as x squared. So now, I can replace this u down here by an x squared. Well, here I'm going to just use the square root property to solve this. And that's going to give me x equals plus or minus the square root of negative 1. And for over here, I'm going to get x equals plus or minus square root of 4. Well, that's going to simplify to plus or minus I. And that's going to simplify to plus or minus 2. So this means I have 4 solutions: negative I, negative 2, and 2. Let's do another example. So here we've got x to the fourth plus 22x squared minus 75 equals 0. So again, I want to do a substitution. I'm going to let u equal x squared. And that means that u squared is x to the fourth. So now I'm going to write this in terms of u. And so I want to look at factors of negative 75, see which ones add up to 22. So let's see. Well, we know it's negative, so one's negative, one factor is negative, one's positive. The 22 here is positive, so I want the larger one to be positive. So I'm going to make negative 175, that's negative 74. 2 doesn't go in there. Negative 3 and 25, bingo. We're right there. Coefficient of the square term is 1, so we can write down the factorization immediately. Minus 3 plus 25. We'll set each of those factors equal to 0 and solve. Here we'll go ahead and add 3 to both sides. Because u equals 3. Here subtract 25 from both sides. So now we got it solved in terms of u. I want to replace u by x squared and then finish solving out for x. So if I use my square root property, that gives me x equals plus or minus square root of 3, so that's done. Use it here, this would be x is plus or minus the square root of negative 25. We have to write that in terms of I, and then square root of 25 is 5, so this would be plus or minus 5i. So my solutions are negative 5i, 5i, negative square root of 3, and square root of 3. Now, the other type we might see is kind of like something we saw before, where this is a higher level ordered polynomial, degree 3. And just think, when I see 4 terms, I want to do my factor by grouping. So the first 2 terms have a common factor of x squared. My leftovers are 2x plus 5. My last 2 terms have a common factor of 4, but I want to take out a negative 4. And then each piece has a common factor of that 2x plus 5. So I'm going to pull that out in front. My leftovers are x squared minus 4. Now looking at that x squared minus 4, well, that is a difference of squares. So I'm able to factor as x plus 2 times x minus 2. So I want to go through and set each of these factors equal to 0 and solve. So I'm going to set the 2x plus 5 equal to 0. I'm going to take away 5 from both sides and then divide by 2. I'm going to set the x plus 2 equal to 0. Subtract 2 from both sides. It's going to be negative 2. And then for the other one, x minus 2 equals 0. I'm going to add 2 to both sides. It gives me x equals positive 2. So my answers are negative 5 halves, negative 2, and 2. Let's try another one. So here, 4 terms factored by grouping. So we're going to factor out a u squared from both terms. That'd be 2u plus 3 is my leftovers. For my last term, well, I need a 2 here, so I want to take out 25, and I want to factor out a negative 25. So that would be 2u plus 3. Now our two pieces, excuse me, my allergies are acting up today. Two pieces have a common factor of 2u plus 3. So I'm going to factor that out. That gives me u squared minus 25 equals 0. And now, just like the last one, this is a difference of squares. And now we're just going to set each piece equal to 0 and solve. So the first one, we would go ahead and we would subtract 3 from both sides and then divide by 2. Second one, we would add 5 to both sides, and then we'll call that one done. The third one, we'd subtract 5 from both sides and call that one done. So my answers are negative 5, negative 3 over 2, and 5. Now let's take a look at this last one. Now it doesn't have 4 terms, so I can't do factor by grouping, but notice each of these terms have a common factor of x. So let's first factor out that common factor of x. So it gives me 6x squared minus 11x minus 7 equals 0. So we're already going to have one answer here, namely x equals 0. And then we need to solve this quadratic equation here to get the other two. Now, we can do this second part by either factoring or using the quadratic formula. It will work out anyway. Just to practice, let's do it by factoring. So if, here I have to use the AC method because my coefficient of my square term is not 1. So I'm going to do 6 times negative 7 is negative 42. And I have to find factors of negative 42 that add up to negative 11. So 1 times negative 42, that's negative 41. 2 times negative 21, that's negative 19. 3 times negative 14, that's negative 11. That's the combination I want. So this x just comes down. And I'm going to rewrite that middle term as a plus 3x minus 14x And now I want to do my factor by grouping. So looking at the first two terms, I have a common factor of 3x. My leftovers are 2x plus 1. And the last two terms, I have a common factor of 7, though I want to take out negative 7. My leftovers are 2x plus 1. And now my two pieces have that 2x plus 1 in common. So I'm going to pull that out. My leftovers are 3x minus 7. And now we're off to the races. First factor, x equals 0. That's done. Second factor, 2x plus 1 equals 0. Go take away 1 from both sides, and then divide by 2. So that gives me a negative 1/2. Third one, 3x minus 7 equals 0. I'm going to add 7 to both sides, and then divide by 3. So I've got my three answers then, a negative 1/2, 0, and 7/3.